Welcome everyone to the Fusion 360 tutorials. In this tutorial, we are going to cover a term that is called design intent. Design intent is very critical when you are creating designs, and it is not limited to any particular modeling package. So whenever you are designing, when you're creating your profile sketches in any 3D software package, you always have to consider your design intent, or lots of mistakes can be made. In this example here, I'm going to show how design intent works, as well as what happens when design intent is not applied to your design or your profile sketches. So in this view here, we have a little simple two-part assembly called Bob and Mike. So Bob has this shape here, which looks like this, and it has these little dowels that are sticking out, little protrusions, and this dimension here, this 4-unit dimension, that is fixed. It cannot be changed. So that dimension always has to be maintained. Bob is going to ask Mike to make this part or design this part to fit on here. So Mike has gone through and he has designed his part, and when we look at that dimension of his profile, that 4.0 units, it is maintained. So the distance between those dowels or extrusions or protrusions is 4. So that is going to fit. It is going to match up with the other part. So always going to fit on there because that dimension is maintained, and tolerances will come into play with that as well too. So it's another reason we want to maintain that in the design intent. So this plate has to fit onto there all the time, and we can see that that has fits on there perfectly. If we look at the top view, those holes are all lined up. So one day Bob comes in and Bob says, I want to make my plate a little bit longer. So Bob's going to make this plate just a little bit longer, and he asks Mike to make his plate a little bit longer so that these edges remain flush. He wants these edges to be flush to each other, so Mike's going to change his design. So Mike goes back into his design and he's going to change his profile from 6 to 7. He wants it 1 inch longer, just like the other mating part. So he changes his dimension to 7, and that rebuilds his design model. And when we go back to the design intent and rebuild that, everything matches still. So the plates are now flush on here and everything lines up. Everything is perfect. Even after that design change was made, there was no other dimensions that had to be changed. We maintain that design intent on Mike's part. What I'm going to show now is if Mike did not put the design intent into his design. So I'm going to go back to Mike's part and I'm going to edit that sketch. So Mike maintained that design intent. He wanted that distance to always be 4, so he actually put that dimension in there of 4.0 units. Now you'll see the length of this object is 6. So we have 4 plus 1 is 5, so that leaves 1 unit down here. So we have the option of just dimensioning. Instead of putting that 4 in there, we can put this 1 in there. So we had the 4-inch centers plus 1 plus the other 1. That equals 6. All is great, right? So we still have that 4 units in between those dowels. So we'll finish that model, and when we go back to there, and everything is fine. Everything fits great. This time Bob says to Mike, I want to change this again. I want to change it from the initial 6 inches or 6 units. I want to change that to the 7 this time. So Mike goes back to his drawing and he says, oh, perfect. I'm going to change that dimension to 7. So he changes that dimension to 7. Now what has happened is we have 7 minus 1, which is going to be 5. That means that we have lost that design intent. This is no longer 4. The design was that this always had to be 4 units in the distance between these dimensions. So because that design intent was not maintained, when someone goes and makes a simple modification, we're going to lose that intent. So if we go back to our final assembly here, we will see that these holes do not line up because the design intent was not captured. So if we did move this down, we could try and move this down a bit, or move that around. You will see those holes do not line up anymore. Just taking a look at the 2D orthographic drawing of this part, we see 2 different dimension versions. So if this was a technical drawing, it may not be, it would be fine. You could probably produce the same part minus some possible tolerancing issues, but you would possibly pretty much get almost the identical part. When you are modeling, it is different because you are actually going in and you are modifying your dimensions in the model. So that's going to affect how everything else changes, shapes and forms, etc. So on the left hand side, with the design intent maintained, this is always going to be 4. So that's great. If we take the 4 plus the 1, it's 5, and we subtract 5 from 6, we're going to get 1. 6 minus 4 minus 1 equals 1. So that dimension, that leftover material or leftover dimension down there is 1 unit, which is the same as over here on this drawing over here. But if we take the 6 overall dimension minus 1, that's going to give you 4, which is the same as this dimension over here. So you think you're getting the exact same part, but when you are modeling, if you don't capture that design intent, when we change this to 7, we're going to keep this 1 unit dimension and this 1 unit dimension. That means this is going to have to change to 5. So it's a little bit different when you're modeling and creating your profile sketches than it is just looking at a print. So hopefully that helps explain the purpose of design intent. The dimensions you want to put into your model are the ones that you use. Don't do adding or subtracting. Don't think that just because the dimensions add up like they do in this sketch, because they all add up to 7, that's not your design intent. Your design intent, you have to maintain what you want that goes into your design so that any modifications can be done and your critical attributes of your design are maintained.